Energy. I mean, think about it. It's everywhere. It's what gets you out of bed, it powers your phone, it toasts your bread. But have you ever stopped to think about what energy actually is? Or, what it's doing when we're not looking? Well, it has this secret life with rules it always follows. And today, we're going to pull back the curtain. Okay, so let's kick things off with a little riddle. What do a crackling campfire, a flashlight, and a hockey puck sliding across the ice all have in common? I know, they seem totally random, right? But here's the thing. They're all connected by one single, incredibly powerful idea. And that idea is, you guessed it, energy.
See, everything that energy does, whether it's the heat coming off that fire or the light from a bulb, it all follows one single unbreakable rule. And if you get this rule, you basically get the key to understanding everything else we're going to talk about.
And here it is, the big one, the law of conservation of energy. Now, this is probably the single most important thing to remember. Energy can't just be created out of thin air, and it never, ever just disappears. It just changes its disguise. Think about that for a second. That means all the energy that has ever existed in the universe is still here, right now, just wearing a different costume. Okay, so that leads to a pretty obvious question, right? If energy never really goes away, what does it do? Well, it turns out it's always busy, always on the move, basically doing one of two things. So we can pretty much boil down all of energy's secret activities into just two main categories. It either moves from one place to another, we call that a transfer, or it completely changes its identity, which we call a transformation. And the difference is actually super simple when you think about it. With a transfer, energy is just getting passed along, kind of like how a hockey stick gives its motion energy to the puck. Same type of energy, just a new home. But with a transformation, wow, that's when the energy actually changes its costume entirely, like the chemical energy inside a battery becoming light and heat. Totally different form. All right, let's dive into energy transfer first. And one of the most common ways energy gets around is as heat, or what scientists call thermal energy. Heat is always looking for a cooler place to hang out, and it's got three main ways to make that trip. And here they are, the three moves heat can make. You can think of them as heat's personal travel options: conduction, convection, and radiation. And believe me, each one works in a completely different way. First up, we've got conduction. This is basically the touching method. When you put a metal spoon in some hot soup, the super fast hot molecules in the soup literally bump into the spoon's molecules, passing that energy right along. That's why the handle gets hot, even when it's not even touching the soup. It's an energy chain reaction. Next up is convection, and this one is all about flowing. It happens in liquids and gases. Just picture a pot of boiling water. The hot water at the bottom gets less dense, so it rises up. Meanwhile, the cooler, denser water at the top sinks down to get heated. This creates this awesome circular flow of energy called a convection current. You see it in weather patterns, too. And last but not least, we have radiation. This is heat beaming through space. And the amazing thing is it doesn't need to touch anything to travel. It's how the sun's energy gets all the way across millions of miles of empty space to warm us up here on Earth. It's also that warmth you feel on your face when you're standing there at a campfire, right? Even when you're not touching the flames. Okay, so that's how energy moves. But what about when it changes its whole identity? Well, that's energy transformation, and this is where things get really, really cool. It's like energy is this master of disguise, just constantly changing from one form into another. And just look at how common these changes are. I mean, it's happening all around us. The sun's light energy gets soaked up by a plant and transformed into stored chemical energy. Then, when you eat that plant, say an apple, your body transforms that chemical energy into mechanical energy so you can ride a bike. It's this incredible chain happening constantly. A flashlight is just a perfect little example of one of these energy chain reactions. The battery, that's holding stored chemical energy. The second you flip that switch, that chemical energy transforms into electrical energy that starts flowing through the circuit. And finally, the bulb takes that electrical energy and transforms it into light. A whole three-step transformation right there in the palm of your hand. So, we've seen energy transfer, and we've seen it transform. But here's the thing. In the real world, these two things almost never happen by themselves. They're usually happening together, in one continuous journey, and there is no better way to see this in action than on a roller coaster. Yeah, a roller coaster, it's just a perfect example of this energy journey. The whole entire ride is just this constant back and forth between two main types of energy: stored energy, which we call potential energy, and the energy of movement, which we call kinetic energy.
So let's break it down. At the very, very top of that first huge hill, the cart is just packed with stored potential energy. As it starts to roll down, that potential energy transforms into kinetic energy, and whoosh, the cart speeds up. Then, as it goes up the next hill, that kinetic energy changes back into potential energy, and it slows down. And finally, at the end of the ride, when the brakes hit, that's friction transforming all that movement energy into heat energy, bringing the whole thing to a stop. So you see, through all of that crazy movement and all those changes, from the top of the hill to the screeching halt at the end, not a single bit of energy was actually destroyed. It was just passed along and put into different disguises. It all comes back to that golden rule: energy is never lost, it's just changed. So now you're in on the secret life of energy. You know its golden rule, and you know its two favorite moves: transferring and transforming. So the real question is, where are you going to see it moving and changing today? Because now, when you feel the sun on your face, or turn on a light, or even just kick a ball, you'll know exactly what that energy is up to.